Okay, Dragons, we want to use this lesson to try to tie in really everything that we've talked about when it comes to quadratics. When you came back from Christmas break, we looked at graphs and we asked ourselves where, if any, are the points where the quadratic, the parabola, crosses the x-axis, and we call them x-intercepts. In this example right here that I sketched out, we would say that our x-intercepts were -2, and that's halfway between 1 and 2, so that would be 1.5. So we would have x-intercepts, again, of -2 and 1.5, and it was just basically a look and see. Look at the graph, see where it crosses, and we also used our calculator functions. We wrote the equation or put the equation in y1, and we went to second calc and we found our intercepts. So that was pretty easy. And then what we did was we went over and we started multiplying using the box method, and we tried to emphasize that it really is dealing with area. We're filling in this area just like a big floor in a room, and we do that by multiplying a length and a width. So if we had a binomial x plus 2 and another binomial 2x minus 3, we went through the process of multiplying each of the lengths and widths of these smaller boxes, noting that x times x is x squared. So this was 2x squared, and then 2 times 2 is 4, times the x is 4x, and then -3 times x was a -3x, and so on, like we've already done. A negative times a positive is a -3 times 2 is 6. And we combine like terms, and we wind up with a quadratic expression, and in this case it was 2x squared, and we combine like terms. 4 minus 3 was 1, a single positive 1x, and then we had our minus 6. We talked about that was in standard form. So my quadratic coefficient was 2, also known as a. My linear coefficient is an understood positive 1, also known as b. And my constant, -6, is going to be my c. So we kind of tied that together to say that this quadratic expression, if I put it in my calculator y1 and press graph, will create this parabola. And this parabola has x-intercepts of -2 and 1.5. Well, what did we do after that? Well, we also came in here and we said, hey, you know, x-intercepts have other names. And we said that x-intercepts can also be called zeros, because the y value has to be 0. So if we take this and actually now say, hey, well, we have a quadratic function, we take this equation, this 2x squared plus x minus 6, and the function is an equation, so we're going to set that. Guess what we're going to set it equal to? We're going to set it equal to 0. Well, if we wanted to find the solutions, what did we just finish doing? We factored this thing. We took this and went backwards. We found out what this was. So we used the GMaps to actually take this, and we can go through the process. But what would we wind up with? Well, we would wind up with x plus 2, one of my dimensions, and then the other one would be 2x minus 3. But because it's an equation, today we're going to find the solutions. So these 2 points over here are the x-intercepts. They're also known as the zeros, but they are the solutions to the quadratic function. So how do we do that? Well, first of all, I want you to pause the video and just take a look at all of this, because all of this is related. It's the same stuff looking at them from different perspectives. This is the factored form of the quadratic. Same thing down here. The quadratics will produce the x-intercepts or zeros or solutions. So my prayer is that when you look at all of this, the graphs, the intercepts, the x-intercepts, the box method, the trinomial quadratic expressions that you get from the box method, and the factoring using the GMAP method, that you can see that it's all part of a big picture. And if you see that big picture, you're in fantastic shape. So today, what we're going to be practicing is we're going to be saying, all right, well, can I go directly from here, okay, to the equation or to the factored form? And the answer is yes, you can. So because my quadratic function is now set equal to 0, here's what we're going to do. If we know what the x-intercepts are and we're trying to build this, we can just work backwards. If we take each of these guys down here, okay, all right, and we know that they're multiplied to equal to 0 because they're part of this quadratic function, okay, we can say, oh, if x is equal to -2 and x is equal to 1.5, we can solve each of these for 0. I know this is kind of weird because usually we're trying to get x by itself. But hey, what's another level of weirdness now? So now what we want to do is not have the x by itself, but we want to have x with some company, and we want 0 to be by itself. Okay, well, let's make a 0 pair here. It's pretty simple, right? How do I make a 0 pair with -2? Well, I would add 2, and what I do to one side, I do to the other. So what is this now equal to? I just kind of made it right there. It's equal to 0. Well, what's on the other side now? Oh, it's x plus 2. Does that look familiar? Does that look familiar? Yeah, it does. Okay, so if we look up here, this -2 is a result of this factor x plus 2. Now, I want to stop right here to tell you that this is where the biggest mistake is made by students. They'll see an answer like x, they'll see this, let me put this in, they'll see this as one of the factors in the problem. I'm just making this up right here. They'll say, oh, they'll give you a picture right here, and they'll say, oh, there's a -2 right there, and oh, there's a -2 in the factor, and students will pick this answer as it being because they see a -2 here and a -2 here. But look what we just did. We had a -2 right here. It's pretty obvious. But do you see that right here? No, you don't. Okay? Because what we have to do is we've got to realize that we start off with x equaling -2, and we have to get x equal to 0, and so we're going to let that 2 come over and hang out with the x, and when we do that, it becomes a +2. So the factor contains a +2, and it produces a 0 of -2. Got to stay on top of that, okay? Because I guarantee you they're going to try to trick you on your EOC. So how about this one right here? How do I get this to produce the other factor? Well, we need to go fractions. We need to say that this is equal to 3/2. Okay? Put that in your calculator, do math, enter, enter, and it'll give you the fraction. Okay? So what we're going to do is we're going to kick that 2 to the other side. So this will now produce what? 2x is equal to 3. And I want this to be equal to 0. I want a 0 over here on the right hand side, because see right there, I want it equal to 0. So how do I make that into a 0? I got to subtract 3, and what I do to one side I do to the other. See, there's my 0, and now what do I have? Well, I have 2x minus 3's, and what do you know? There we have it. Okay, so if you take a look, go ahead and take your handout. I'll run through problem number 1 with you. Okay, show you how to do it. and then you can either take off and finish the rest of them, or you can ask your wonderful instructor to maybe help you out with some of the other ones. Okay, so right here it says to graph. We're going to sketch. We're going to sketch it. So we're just going to type this in, and we're going to go to our graph, and we're going to take a look at it. If you're not sure, let's go ahead and let's practice our calculator keystroke to find our zeros. So let's do a second trace, and let's find our intersections. I'm sorry, or zeros, excuse me, zeros. It's late. All right, so we need our cursor. Remember, we got to do these one at a time. So I need to be to the left of one of my zeros. Right now that's to the right. So I need to kind of move it, and okay, so it's a little bit to the left. That's good. Press enter. And now I need to be to the right of the same target. So I'll go back up and press enter twice. All right, so this one has a 0 of a negative 0.5. So on your graph, come over here and go to a negative 0.5. Okay, again, we're just sketching it. Okay, and if we go to, maybe get lucky, can we go to our table? We find, oh, there it is. There's our other 0. Our other 0 is at a negative 50. Sometimes it's in your table and sometimes it's not. Okay. And if we look down here, our vertex is somewhere around negative 310. So let's put that point in. 1 to negative 3, and then negative 10 is all the way down here at the bottom. So we're just going to sketch it. We're not going to worry about being perfect. Okay. But we do want to make sure that we have these 2 points exactly as we have. So we're going to come over here. Our zeros were, if you remember, we said it was negative 5, and the other one was a negative 1/2. Okay, so now we're going to do what I did on the previous example. We're just going to start with this. Both of these, got to do both of them. And what we're going to do is we're going to take each of these and set it equal to 0. So x minus 5 is one of my zeros. See why they call it zeros? It's one of my zeros. All right. X equals negative 5. Boy. That's why you use pencil. Okay, x equals negative 5. And yeah, this fast. I'm sorry. Have your lawyers call my lawyers. All right, so now I'm going to set each one of these equal to 0. I need to get away from the blue. Blue's bad luck. Alright, so I'm going to come over here. I'm going to add 5 because that makes a 0. And what I do to one side, I do to the other. So I have x plus 5 is now equal to 0. Okay, so I'm going to put that right there as one of my factors. And then I'm going to do the same thing over here. Now, again, if you have a decimal, you need to write it as a fraction. If the fraction, take your denominator, kick it to the other side. So now I have 2x is equal to negative 1. And now I need to form a 0. Well, what makes 0 out of a negative 1? Hopefully you said plus 1. There's my 0. And so I'm left with 2x plus 1 is now equal to 0. Okay? So now, let's see if these two factors, if I multiply them out, will produce my original problem. Okay, this is actually just good review for your upcoming test. It goes over all the different aspects of quadratics. Okay, so x times x is always x squared. And multiply it by 2, you get 2x squared. 2 times 5 is 10, times an x is 10x. 1 times x is just a single x, and 1 times 5 is 5. Like terms are right here. We combine like terms. 10 plus 1 is 11. So I wind up with 2x squared plus 11x plus 5. And what do you know? There we go. It's exactly what we want. You could also put it in your calculator, and we say yes, it is the original equation. And that's what we're going to do today. See ya.